Thank you so much, Lisa, for coming and joining us today. Lisa comes to us from the University of Lausanne, in Switzerland, and she has completed her PhD and is now currently a postdoc in Switzerland on organisational culture, social learning, cultural evolution, all kinds of wonderfully interesting topics, and we're very excited to have Lisa come and join us today. You're visiting the Department of Management right now, and we were super excited to have the opportunity to hear Lisa give a talk then while she's visiting Aarhus. So we will do our usual 45 minutes and then some questions at the end. If there's any clarification questions, I think Lisa is happy to take them as we go. I've explained to Lisa we normally have sandwiches after the talk as well, and so we can hopefully have an intimate and interesting discussion about Lisa's work there too. Good. Thank you so much, Lisa.
Thank you, Christine, for the nice introduction, and thank you all of you for being here and having me give a talk. I'm always super happy to present that piece of research because so I'm coming from Switzerland, and it's a nice opportunity to make you discover a bit more about Switzerland. So I hope, I know it's a tough week, I learned that for this department, and I hope I can entertain you a bit for the next 45 minutes. So this talk will talk about the causal identification of culture, so how culture can shape choices related to fertility and mortality, and trying to make a causal claim about the effect of culture. This is a joint project with, does that work? Yes, with Raphael Lalive and Charles Jefferson, who was my PhD supervisor. So we start with the idea that social learning can lead groups to differ in the same environment and drive selection on genes. And this is the very basic assumption of gene-culture coevolution. And what that means in other terms is that social learning mechanism, that is culture, can create stable differences between groups in ways genes cannot, and then influence selection on genes. So if we imagine we have very same environment, the exact same population, same genetic distribution, same institution, thanks to social learning mechanism, we could observe different behavior. And that would be the true cultural difference. And this is an assumption we need in gene-culture coevolution. However, identifying the causal effect of culture in the field is the challenge. We often compare two countries, Denmark and Switzerland. We observe different behavior and we assume that is a cultural difference. But from a strictly empirical perspective, actually we cannot know. Because between these two countries, maybe culture differs, but there's also many other confounds, such as the weather, the climate, the topology of the environment, the institution, the history of the two populations. So if we observe a difference between two countries, we cannot really say that it's a cultural difference. And we also observe that even within countries or within groups, there are also a tremendous variety of behavior. So we cannot do that. What would be a much more convincing situation would be if we can have in the very same environment, same genetic structure, same weather, a behavioral difference. And this we could assume that if only culture differ, then it's a cultural difference. So that's why we are trying to do here. We produce that setting where we have in the same environment and controlling for everything but culture. If we observe a difference in behavior, then we could assume more safely that this is a cultural difference. And that's what we are trying to do using the Rösti-Graben, which I will talk about in a minute, a regression discontinuity design, which is an econometric technique, and some data about referenda in Switzerland. So the Rösti-Graben is a language on cultural border. Rösti means actually mashed potatoes, and Rösti-Graben is the border, so the border of mashed potatoes. And this is because we assume that some people in the German-speaking side of Switzerland are eating more potatoes than the people in the French-speaking side of Switzerland. So we have in Switzerland a few different languages, but we have French and German. So we have here the French-speaking part of Switzerland and here the German-speaking part of Switzerland. Here we also have people talking Italian, and here people talking regression, but we won't look at them today. And what is interesting about this language border, it's also perceived as a strong cultural border, and in some part it will cross the cantons that are the bigger administrative units of Switzerland. So you can really have in the same canton the two languages spoken. And as I mentioned, it's perceived as a cultural border because we have some stereotypes about how one population will behave and how the other population will behave in the same situation. And these stereotypes are shared across the two speaking regions. And we also have difference in average belief and behavior related to health and fertility on both sides of the border. However, as I mentioned, having only average difference between the two groups is not enough, as we are not controlling for other things. And that's just to show you the difference of the language. So you have on the x-axis the distance to the language border, 0 being the Röstigraben, and you have the French and the German speaking part here, and here the proportion of the population that would be speaking German at home. As you can see, there's really a strong discontinuity at the border. Even though people are traveling across the border every day, we still see an increase that is happening in a few kilometers from one to the other side. And I mentioned the administrative units of Switzerland, so here's to give you an idea. And these are the cantons, so the bigger administrative units, and the border is really crossing some cantons, crossing the canton Vienne here, Freiburg here, and the valleys here. So we have this really nice setting where we have a language and cultural border that also crossing some cantons, so you can more safely assume that the institutions are the same on the two sides of the border. The second tool we use is a regression discontinuity design. So I'll talk about that in a minute. It's a tool that allows us to identify a local causal effect. So we said we have Switzerland here, and let's say we have data, for example, much more data. So in this study we're looking at municipality level data. So this will be all the municipality we have. And we have the data for these municipalities, but what we are interested in is what's happening right at the border. So the regression discontinuity design allows us to do exactly that, to take all the data we have on the two sides and estimate an artificial behavior distribution at the border. So what we do, we decide how many data we would like to include, that's the bandwidth, then we raise the others, and we estimate what would be the behavior right here. So we are not estimating an effect in whole Switzerland, we are really estimating the effect only at the border, using all the data but creating an artificial behavior distribution at the border. So this technique allows for a causal but local effect right at the border. When we use this technique, there is the continuity assumption, that is that if we would like to identify the effect of culture, then we need to be sure that at the border only culture is changing. So we have to check for other variables that could be influencing that. And here the main table about the variables we looked at. And basically these are not regressions, it's really just to give us a sense, are the populations the same on the two sides of the border? We know they are in the same cantons, but might be other variables changing. So we look at the population size, the population variation, the density, the migrants population, some about age distribution, and some about the finance of the people. And what we observe is that some variables are different for some reasons. We are interested mainly in what's happening at the border. There are more immigrants in the French-speaking part of Switzerland. The population is younger and pay less taxes, or pay more taxes, so has a bit less revenues. And we don't know where those differences come from. Maybe they come from culture, maybe they come from something else. but we would like to control for them as they are not all continuous at the border, so we also add them in the analysis. Also, we can also say that the younger population is part of the culture. We say, okay, for now we just control for them to be sure we have only culture changing at the border. And if we look at maybe 2 examples, the household composition doesn't change much, but that lets you familiarize with what regression discontinuity graph looks like. You have the distance from the language border here. Negative distance, the French-speaking part. Positive distance is the German-speaking part. And here you have a measure of the household composition. And what we are looking at is something happening at the border? Do we have a discontinuity or not? In that case, we don't. If we look at the tax ratio for single individuals, then we have a slight difference at the border. And we can also observe that it's decreasing as much we are going away from the border. So this is just things we are controlling for in our setting. The third tool we need, we have first the Roche-Graben, second the regression discontinuity design, and the referenda data. So you might know that in Switzerland we vote many times, multiple times a year on many different topics, and that's good news for us. So the data are available publicly at the municipality level, and there's something really important for this technique, regression discontinuity design, because you need a lot of data that are have a quite good geographical precision, and this is often hard to get for some privacy reasons, especially if we are looking at subjects like health and fertility. So we have this data at the municipality level that are publicly available, and we can locate them on the map. So we selected 6 referenda, the latest 6 referenda that were closely related to health and fertility. We ended up with 3 referenda related to health. The first one about a single public health insurance company, second about the revision on the law of epidemics, and the third about the COVID law. And on fertility we also have 3, the referendum for the non-reimbursement of abortion, the referendum on assisted reproduction, and the referendum on paternity leave. Just to give you a preview of the results, all these 6 referenda, 4 of them appear to have discontinuity at the border, 3 related to fertility and 1 related to health. But I'll talk more about some of the results just now. And I would like to start with the health-related voting behavior. And we took as an example the unique public health insurance company. So the question was asked to the citizens of Switzerland, would you like to have a unique public health insurance company? So to give you a bit of an insight about how the Swiss health insurance system works, we have about 60 private companies that each provide health insurance. And you have to subscribe to one of them, and the average monthly premium for basic health insurance was 447 Swiss francs in 2007. I did the conversion in Danish krone, and which is 3,800. So it's quite a lot, and it's something that is often discussed in Switzerland. How can we reduce this cost? Because you pay this, but you can imagine that if you pay this, then it means you will also have to pay a first 2,500 Swiss francs when you go to the doctor. Basically, you have a franchise that you have to cover before. So it's a lot of money, and we're voting often on these questions to try to reduce the cost. And one idea was to have only one public health insurance company, so you reduce all the costs due to marketing, etc. And here are the results we found. So again, you have the distance from the language border here, the Roche-Graben at 0, the French-speaking part and the German-speaking part. And on the y-axis, you have the percentage of yes vote in each municipality. And each dot represents either a municipality or group of municipality. And you have the true regression line for the regression discontinuity design. And what you can see is that at the border, we have a clear discontinuity that also appears nothing else in the data. So from this, we can, if we assume that at the border only culture is changing, then we have a cultural difference here, that culture will drive different answer to the referendum. And if we start from this first causal difference, because we are looking at votation that could be related to health and fitness, we do one step more. So we do the thinking experiment, thinking, okay, what are really the citizens doing here? So they are choosing between, at one extreme, a single insurance company that pool over the risk of the entire Swiss population. But the other extreme would be that everybody would self-insure. And we can imagine that this system could have an impact on the individual fitness of the population, either because you are paying all the costs for yourself or you have to pay for the other, and that could influence the fitness. And whatever the details, so you're not really saying that one is better than the others, but so whatever the best system in terms of individual health, if we assume that at the border there is one trade-off, one balance of policy that is better than the others, then that means that at the border some people were ready to support a cost in terms of individual fitness to uphold some cultural values. So we identify a causal difference here, and from this discontinuity, because we are looking at validation related to health and fertility, we make one step more, thinking, okay, could that have an influence on genetic fitness in the end? So that was for the first example related to health. There's a regression table, I don't want to look at it. And then I would like to present an example about fertility-related behavior. And this one is about the reimbursement of abortion. So the question that Swiss citizens had to answer is, would you like to stop the reimbursement of abortion? And it was not so long time ago, it was 2014. So to give you a bit of a background, so abortion has been legal in Switzerland since 2002 and is covered by the health insurance I mentioned. And the question was, would you like to stop this abortion? The people that suggested this initiative said you should not pay for something that you think is morally objectionable. So the abortion rate is stable and low in Switzerland compared to other countries. So it's 5.1 for 100,000 women. And you have the other numbers. It's 15.5 in France versus one of our neighbors, 5.4 in Germany for the other neighbors, and 12.2 in Denmark here. And here are the results. So you have again the distance from the language border on the x-axis, and on the y-axis the percentage of yes vote for the initiative. And what we see again is that we have a clear discontinuity here at the border, also something that would not appear anywhere else. So if we assume that we did the regression discontinuity design correctly, and that at the border only culture is changing, again we have a cultural difference in voting behavior related to fertility. And doing again the next step, do we think that reversing abortion could have an impact on genetic fitness? So we imagine yes, if we assume that humans are cooperative breeders, then you need multiple people to raise a child. Women need that freedom of choice to manage the trade-off between a current offspring and a potential future offspring. So in that sense, any limitation on women's ability to manage this trade-off would impose a fitness cost on women. So seeing this cultural difference here, imagining again that at the border one policy was better in terms of individual fitness than the other, we can also say that for some cultural reasons one population was ready to uphold a cost, in this case a fitness cost on women, to uphold some cultural values. And this was for the second example. And we did that for the 6 referenda, as I mentioned. On health, we found 1 discontinuities, and for the fertility-related referenda, we found 3 of them. To conclude, so I would say that identifying the causal effect of culture on health and fertility is a challenge. As I mentioned, we often compare two countries imagining that there would be cultural differences. However, the reality is much more complex. So to meet this challenge and to identify causal effect of culture, we combine here language border in Switzerland, the regression discontinuity design, and some referenda data. What we found is that culture can indeed create stable differences between groups in domain related to health and fertility, where we make sure that cultural explanations are distinct from institutional, genetic, and environmental explanation. And I think that's even more fascinating knowing that we have people traveling across this language border every day, thousands of people, living on one side or the others, meeting each other every day, but still we have these differences that are stable and that persist in the population. We made a further step showing in a thought experiment how these cultural differences could affect the relative fitness of individuals in the two cultural groups eventually. And in the next step, so we have a follow-up project on that with data from the statistical office. I think one main limitation of the study is that the municipality level data and fitness happen at the individual level data. So we have now a second set of data with individual level data that is representative of the population of Switzerland, which is survey-based but covered health in a really broad sense, with physical activity, nutrition including how much alcohol, drugs or tobacco do you consume, some biomarkers about BMI, blood pressure, cholesterol level, and some mental health related questions. Also, how many times do you go screenings for some types of cancer, etc. And now the big questions we have, and I will be happy to discuss with you further afterward, is which one to select. So we have this huge database about all these variables, and our question is what really makes sense in terms of fertility, health, and ultimately individual fitness. And it's a much more complicated question than I expected before. In terms of personal next step, so I will be in Oz from July 2025 for 2 years. I will be joining Dorte and Eric in business school, and I will be working on organizational culture and social norm change in organization. So I will be there again next year. And on that, thank you very much for your attention. And I realized I was much quicker than expected, but I'm happy to have more time to hear your questions and thoughts. Thank you.